Okay, you should have printed out or downloaded the syllabus. Who is coming in? What's your first name? Amy. Amy. Okay, so you are going to be, yeah. Okay, here's the syllabus. Okay, my office hours, so again, Mark Ashbrook, email is the best way to get a hold of me. These are my office hours. Monday and Wednesday, not Friday, notice that, just Monday and Wednesday, 1:15 to 2:30, Tuesday 11:30 to 12:30, and then were your office hours confirmed? So this he's going to be sitting in on the class. He's actually the teaching assistant for the other calc class, but he can help you also. So what are your office hours?
Mine are Monday and Wednesday from 3 to 4:30.
And this is, by the way, this is Marshall. You said what?
Monday and Wednesday.
Okay.
3 to 4:30.
Good.
And I'm PSA 826.
Monday and Wednesday, 3 to 4:30, PSA 826. So this is Marshall. And so he's going to be sitting in and learning it, or learning this style of the calculus, just as you are. So myself or him are going to be your first lines of defense for help. If you go to there is the main tutoring center, but if you go there, they may be a little unfamiliar with the things that we're doing. So I would recommend my office hours, Marshall's office hours, as your first try, okay? So course materials we talked about last time. Who's coming in? What's your name?
Eric.
Eric. You're at that table. Right there where you're sitting. Very good. Okay, everyone got Marshall's info? I'm going to take this off. We've talked about the course materials, the Briggs and Cochran textbook. Really for our course, we'll just be using the online homework occasionally. Okay, so not extensively, but occasionally. But the textbook you will need for the future calc course, and reference if you want to use that for reference. Okay, Blackboard, you should have visited Blackboard by now. Graphing calculator. I haven't gotten hardly any emails. Is everyone able to download it? Okay, if you don't have it by now, please talk to me after class if you've tried and you're having difficulty. But we should have it by now. You need access to a printer. Here's some special dates: Labor Day is a week from today, fall break, some different. We got a day off for Veterans Day, etc. So homework. I'm not going to read through this, but some highlights. So correctness, maybe a small part of the grade, but presentation is going to be the most important thing. Okay, complete sentences, good organization, diagrams where necessary, logical derivations, okay, are all part of a homework assignment done well. Okay, you're going to be doing a lot more writing than you're used to. I'm going to ask you to explain things in sentences. Okay, this is really important for you to solidify the ideas in your mind so you really understand it. Okay, so because correctness is less of a less important in terms of your grade. So I'll be posting solutions after you turn it in. So that will minimize the time we spend doing lots of going over the homework. So you can go study those solutions. If you're still having difficulty, then that's the time to come and ask. Okay? So that'll save us a lot of class time of doing half the homework each day. You can read the rest of that. Putting in regular time to do the homework is going to be imperative for your success in the course. Okay? Quizzes are going to be during recitation. So recitations for us are tomorrow, Tuesdays. Okay? And we'll be doing some kind of catch-up, review, examples, and quiz every time for recitation. Okay, Math Testing Center. you're going to be, so we'll get practice at this with the pretest, which is today. The pretest is today. PSA 21. That's on the Palm Walk, just a little bit north of here. About a 3-minute walk down the Palm Walk. PSA 21 is in the basement. You need a sun card. For the pretest, you will not be allowed a calculator. You don't need to study, but you do want to do your best, okay? We're going to see, kind of gauge where you're at. And also, you can get some extra credit on exam 1. Okay, any questions about going and taking the pretest today? The hours, they open at 10:30, so you can't go right after class. But starting at 10:30, then you need to be in the door by 6:30. Okay, they close the door at 6:30, but if you get there at 6:15, you have time to work. They collect the tests at 8:15 if people are still there. Okay, so just as long as you enter any time this afternoon, I would guess that this will take, on an average, 40 to 45 minutes. Some may be out of there in a half hour. Some you take longer. It'll take an hour. I'm guessing about 40 to 45 minutes. Okay, do your best. You can earn some extra credit. The other tests will be the same procedure. The first one being Thursday, September 13th. Any questions about taking tests? Yes, sir.
Should we bring a calculator?
Not today. I'll let you know about future tests.
Okay.
Yeah, so I'll let you know on each one. It may be different on each one, and I'll let you know. But today, no calculator.
Do we just walk in and say there's a test for Mr. Ashby?
Yeah, there's a check-in desk. So just have your sun card ready, and they'll hold your hand and take you through it.
Do we have pencil and paper to do work, or do we?
Okay, so you can't have your own scratch paper, but if they have scratch paper at the desk, you just request it right there, say I need some scratch paper, and they'll give it to you. Okay, but you can't use your own. Good questions. Any other questions? Okay, and then halfway through the semester, we'll also have this other thing called the mastery exam, and we'll talk about that as the time gets closer. Okay, so you can read all the fine print on attendance. It's because of the nature of how we're doing this, it's going to be imperative that you come to class. The discussion is the most important thing, the discussion that we have. And your chance to think and start forming these ideas in your head is going to happen here in class. If you miss class, you're going to feel behind. Okay, you're going to really feel behind. So, absolutely mandatory. For this class, something like 6 or 8. So we meet 4 days a week. So more than 8 absences, and that's an E in the course for non-attendance. Okay. So here's the thing, there's no excused and unexcused absences. You've got this cushion of 8. Whether, your alarm clock doesn't go off, or, you had an emergency or things like that. That's your cushion of 8. So don't email me like in terms of this is excused or unexcused. Yeah, so in terms of getting caught up, we'll have the movie. You can watch the movie. If you have a question about what's assigned, you can email me about that. But if you miss a day, it's just one of your 8. Doesn't matter the reason. Does it make sense? Okay. Okay, so again, the discussion in class is critical. So participation is going to be to your benefit, that you're engaged, asking questions, working with each other, of course, paying attention. Here's the breakdown for grades. Homework participation, 20%, recitation, 15%, so that includes your quiz. And attendance for recitation, tests are 45%, final is 20%. So the homework participation at 20% is both the written and the online combined, okay? Here's how once I get a number for you at the end of the course, here's how I'll award letter grades. Okay, the course policies and university policies, I'm not going to go over it. Common sense. But even though I'm not talking about these things, you are responsible for all of them. Any questions about the nuts and bolts of the course? Yes, ma'am?
For the online homework, is it due like midnight, or is there a different time?
I usually, so different teachers do it different ways. I usually make the online homework due like a half an hour before class. So you can work on it all night if you want. So what time do we start? 9? So I'll usually make our online homeworks due 8:30 a.m.
So there's like no different time or whatever, because I really on my math lab like
Uh-huh.
over the summer for other courses, and there's a 3 hours different time zone. They never told me.
Yeah, so your teacher didn't set Arizona time. Was it here?
Yeah. It was
Yeah,
like
your teacher just didn't get the right time zone when he set up the homework.
I assume like.
Yeah,
it was
no,
like 3 hours.
so I know how to do that. So when it says it's due at 8:30, that's 8:30 Arizona time. Yeah, there won't be any issue with that. Other questions? Yes, ma'am. No, not the online homework. The online homework is the exact opposite. It's like kind of like drill and practice. The online homework is going to be like when we get to actually solving derivatives. That's a required part of the course. It's not my preference because we know we can do all those with a computer, like we talked about last time. But the online homework is going to be more like, here's a problem, you solve it, and you type in the answer. The writing is like the kind of thing you're going to hand in today. Other questions? Yeah, sure.
I have a class that ends 10 minutes before recitation starts. If I'm there a few minutes late, am I gonna get?
No, you're fine.
Okay.
Just do your best.
Just making sure.
Do your best. Other questions? Okay.
Going into the testing center to take exams and all that, do we still have to buy Scantrons or they have?
No, they have the Scantrons for you. Yep, you just need a Sun card and then maybe a calculator, I'll let you know. But no calculator today. Okay, don't forget to take that pre-test today. Okay, so we have homework coming in. So when you turn in the homework, this is what I want you to do. This helps for organization, and also if you forgot to staple it, this will solve that problem. So just take all your work in the stack like this. And I want you to fold it. This is the front page. I want you to fold it right towards yourself, right like that. Right down the middle. Okay, I've got 100 students in calculus and another 80 in pre-calculus, so these details are important. All right, so you fold it towards yourself, then turn the open side to the right. Looks like a book. Okay, now you're looking at the back of the last page. That's where you want to put your head. Let's just use it here. Here we go. So this is what it looks like. So you're holding it like that. See it? Okay, so you can put the heading right here. Okay? And you're going to put name and 2:79 a.m. and the date, which is the 27th, so 8/27. That's going to be the standard heading.
You want the due date or the date we do it?
8/27. We put 8/27. Yeah, so it's the day that you turn it in. So just, you can do that when you walk in the classroom, and you're going to put that day so it's all the same, so I know what day it was due and which assignment it is. Okay, then you can fold it up and you can stack it in the middle there. Oh, before you do that, we got our quiz. So grab it back. The quiz is going to be at the end of the last problem. Okay, here's the quiz. Everybody's working by themselves. Okay, do I have to change that table up over there? Okay. Just the answer. Everyone's working by themselves. No talking. So, it could be more than one answer. It could be one or more of these. Okay? It said that talked in the reading about one or more of these was particularly important in calculus. So you first answer either one or more of these, and then explain in complete sentences. Okay? You got a couple minutes. Eyes on your own paper. Okay, and so if you're done, that should be, should be at the end of your homework. Put it in with the end of your homework. Still got a minute or so. Keep writing. What's up? Wait, it's a question, yeah. What's that? Okay, it's on Blackboard. Go to the Blackboard and go to assignments. What's there? Yeah, sure. Turn it tomorrow. No, so that's what folding, when you fold it up, it'll stay in there. If you rip out of a notebook, you always give me a clean left edge. Always give me a clean left edge when you're in alignment. Okay? Yes, sir. I can't hear you. I still can't hear you. That's okay. Yeah, I told you to put it at the end, at the back. It's fine. Yeah, just as long as your heading's in the right place. Okay, so can you give me a clean left edge there, sir? Yeah, there's no way I could. Yeah. All right, everyone's done? Okay, let's see. Where's Isabella? Do you think you got this? Tell me what you put.
I put it's subtraction and division.
She said subtraction and division. Yes? She got it. Subtraction and division. So everyone, we're done writing now. So stack them up in the middle. Okay. Subtraction. What does it represent? Remember what it said? Subtraction represents. Let's see here. Where's Danny? Remember what they said subtraction represents?
The difference between two quantities.
Okay. Difference between two quantities. What about if it's the same quantity? What would subtraction be if it's the same quantity?
The overall change.
Yeah, the change, right? So it's like the change in a quantity, okay? Or the difference between two quantities, right? Now what about division? Where's Erica? Do you remember what division meant? Okay. Anybody? What did it say about
So
the?
the
What's your
rate
name?
of change between two different values.
Okay. Division is where we get rate of change, and we said rate of change is like the underlying idea of the course. Okay. So we're gonna keep looking at quantities here. Any questions before we start? Wow, that took a lot of time, but okay, we needed to do it. Okay, that being said, you in your reading, you read about this. Which operation gives a scaled version of another quantity? Remember what this would be?
Multiplication.
She wants multiplication. Agreed? Right. Okay, so example, a tree's shadow is 3.5 times as long as the tree is high. Okay? So a tree shadow is 3.5 times as long as the tree is high. Okay, how can we use the bars to represent the situation? Is it Sterling?
Yeah.
How can we use these bars to represent this situation that a tree shadow is 3.5 times as long as it's high?
So we can use that smaller, break up that smaller one.
Okay. Well, let's decide what they mean first. So before we're even there, what do these bars mean? What do they represent?
Long bar represents the tree shadow.
Okay. What about the shadow? Is the bar the shadow? So really, it's the length. So the shadow, it's not the shadow itself, but that bar represents the length of the shadow. Okay? And what about the smaller bar? Yeah, sure, the height of the tree. So how can we make sense of this as multiplication? How is it that multiplication makes sense here? How can we use the bars to show that it's multiplication? Anybody? Want to keep going? Okay, right. So the shadow, if we break it up into tree heights, how many tree heights will it take? And a half. Okay, so we have the height of the tree multiplied by 3.5, we get the length of the shadow. We're scaling up this height quantity to get the length quantity. Scaling or magnifying. Scaling can also be shrinking. Okay, so multiplication is about scaling. All right, what about the number of checkers in 12 rolls is 12 times as large as the number of checkers in one roll. How does multiplication make sense in this situation? How can we represent it? Tell me your name right here.
Me?
Yeah.
Jessica.
Jessica.
Well, the top bar would be the number of checkers in 12 rolls.
Let's say number in. Okay. And?
And the bottom would be the number of checkers in one roll.
Keep going.
And that top bar represents 12 checkers. Or, well, it's 12 times as many checkers as that bottom bar.
And how does it?
Because it takes 12 of the bottom bars to break up into the top.
So pretend this is 12. Okay. Right, so we've got the number of checkers in one roll. Using multiplication times 12, we scale it up to the number of checkers in 12 rolls. Any questions? Is it good? So this may seem really elementary and easy today stuff, but that it's really, this is the underlying idea to the way we have to think when things get harder. When we start really getting into situations with changes of quantities and rate of change, we're laying this foundation of how we have to think when it comes.
So this class is going to be majority of word problems, more or less than.
Well, the real world application will usually motivate what we do. So it's going to be kind of reverse. Maybe what you're used to, a lot of math classes you might have been in, you did a lot of practice kind of just moving the symbols, and then kind of as an afterthought, it's like, okay, here's an application problem. And that maybe you kind of didn't spend as much time as you should have on that. So the reality is that the need for mathematics comes from things in the world. So we're going to start kind of with applications and develop ideas out of applications. So yeah, that's a good point. Okay, questions on this? No, that's not what I wanted. Okay, let's think about this. So, still talking about multiplication, a scaled version of another quantity. A car travels at 67 miles per hour for 3.2 hours. How can we represent this situation? So think about it. Got some just blank sheets for you to work on here. So think about that, talk amongst yourselves. How can you represent this situation? Let me know if there's not enough on the table. Yes, sir. Not enough? Just take a minute, see what you come up with here.
So really it'd have to be like 1 mark here.
Straight edge.
3.2.
Oh, that's okay. That's okay. Look, when you take this off for me. This here. Plus. Okay, so you're gonna have to get a notebook that has you can tear it off. Okay. And then also the heading goes here. Yeah. Good. Okay, does this feel the same or different than what we just did? With the tree and the checkers? What do you think? Did it feel the same or different?
It's just once you figure out like the initial where to place the hours and miles per hour.
Okay, so I'm not kind of talking about how to do it, but rather just comparing the situations, what you're doing. Is it different or the same? Okay, why is it different?
I think it's different because like
time changes, like it could be 3.2 hours or it could be a different time. Then, like for the checkers, it was just like the same quantity.
Okay, so she's saying that, so what I hear you saying is the difference between constant quantities
Yeah.
and varying quantities. Okay, how did you assign the bars?
I assigned the longer bar as hours and the shorter one as minutes.
Okay. Can we do it the other way around?
Probably.
Let's do it the other way around. Okay? Number of hours you could have here is the lower bar. And what quantity is that representing? The whole bar. 3.2. So what am I showing right here? 1 hour. Okay, what about the top bar? So we can do this however we want. We can choose to let these bars represent anything we want. What makes sense for the top bar in this scenario?
Or I know it'd be an unknown, so you have to break it up into
But what I'm asking, what quantity? What quantity is that top bar going to represent?
total miles.
What's that?
Total miles.
She wants total distance. Does that make sense? Yeah, that makes sense, right? Because as the hours change, does the 67 miles per hour change? No, the speed's staying the same. So really, we want the distance traveled. Okay? So, just how long is this bar then? What is the quantity of that bar? Is it 67?
67 times 3.2.
It's not 67, right? So what does it represent? Not the number, but what does the length of that bar represent then? If
3.2 times.
no, what does the number represent? That's a number.
67 miles per hour, by each hour.
But what? So tell me your name.
Jason.
Jason.
Number of miles traveled over 3.2.
It's the number of miles traveled over 3.2 hours, right? So if these are corresponding bars, and we know the number of hours is 3.2, then the length of this bar has to be the distance traveled in 3.2 hours. Do you see? Okay, good. So what about in 1 hour?
67 miles.
So how are we going to get the number of hours, or sorry, the distance traveled in 3.2 hours? So this is in the first hour we go 67. How much do we go in the second hour? And in the third hour? And then what's this? 2/10 of what? 67. So which quantity? So we saw like with the shadow was the scaled version of the tree height, right? So which quantity is getting scaled here? This is why this one's different. What's getting scaled here? What's that? Total mileage. Is that right? Is that it? It's different. Why is it different? Yeah, why is it different? Yeah.
There's two different variables in this one.
Okay.
You have time and you have distance.
So they said the distance is getting scaled. Do you want to add anything?
Time and distance are being
They
scaled.
both are getting scaled. You see this? Both get scaled. The time gets scaled from 1 hour to 3.2 simultaneously. The distance is scaled from 67 to 3.2 times 67. Oops. It's not hours, right? Oh, no, I had that right.
So if we were doing this in a problem, you wouldn't want the overall distance, you would just want it scaled like that?
What do you mean? It's 3.2 times 67?
Yeah.
Is that the overall distance? No?
I mean, if you add it up, yeah.
3 points. Okay, yeah,
Or
so
you just want us to leave it like
so okay, so again, it's about the process, not about getting an answer, okay? So there's going to be lots of checks here kind of within you, you know, so you've internalized the culture of math in the past. And what's part of the culture? Get an answer, right? Get an answer. Is this any less valid than what we would get if we multiplied 3.2 times 67? Is it any less valid? No, it's not. And actually, so and there's an advantage to this, and then it's kind of showing the process, right? So 3.2 times 67, or what is the number? I'm sure some of you have done it. 214.4? Both are absolutely valid. Okay? And so, and you know, watch out for what does he want from me? What does he want from me? So I want something that makes sense. I want something that makes sense, okay? That's what I want. And there's going to be many ways to do that. All right. Any more questions about this one? So this is showing scaling two different. Get this right here. Try this one. Car travels 67 miles per hour for 0.002 hours. Exactly the same as the last one? You want to approach this slightly differently, okay? It's kind of the same setup, kind of feels the same, but then you start thinking about it, you want to, in terms of representing it, you want to approach it a little differently. Okay, so share with someone next to you. So that's always the encouragement.
Exactly. It also gives you that type of equal like one section. The scale is the same no matter what you want. I think that's the point. So look, even like before, this is the same scale no matter how you want it. So that's the point. Yeah. Well, yeah, that's what I get was I'm drawing. You could tell
I know that.
Where's Patrick? Patrick, you're up. Tell me what you did. Or how did you think about this, I should say.
We didn't get very far, but we're trying to figure out if we should break that 0.002 hours into maybe a smaller numeric, like seconds or minutes.
Were you thinking that, so what I hear you saying is you're thinking that this whole bar should be 0.002 hours.
Right.
Okay? What do we think about that? Is there another way to approach it? How about making it 1 hour? So we can make this 1 hour. And if this is 1 hour, then what would this be? Okay, and so how can we use multiplication? How do we think of multiplication as making sense of this situation?
So you would break up the 1 hour into 2,000 of an hour.
Okay,
And then you would do like 2,000 of 67 months.
okay,
So you put 2,000 of those.
okay. So 0.002 is, this is 2 1,000ths of 1 hour. Is that little thing right there. So then what distance must that be? 2 1,000ths of 67. Or I will do my best to see if I can make my writing a little better as time goes by. I'll work on it.
Is
Okay.
there a screen for this side? Because it's kind of cut off by the board.
Yeah, thank you. Okay, any questions on that?
If you
Yeah.
chunk the scale, it's like, because that's all we did. We set the bottom bar to 0.02 hours just
Okay.
to make it more visually
Okay.
comparative. That isn't wrong. That's just different scale.
Okay, so then how would you go about it from there? So that was what Patrick suggested also,
Yeah.
okay?
So we started at the bottom with 0.02 hours, split it up in halves, just to kind of give us a visual representation of like
Okay.
0.001 hours, and then represented the top being just those distances, so 0.001 for the first half of the long bar, 67 miles, and then the second bar being the full 0.002 seconds of the.
So you made 0.001 hours correspond to 67 miles?
No, not 67 miles, like that times 0.001, no 67. We didn't do the actual calculation, but that's the representative amount. 67 times 0.001, and then the full bar being 67 times 0.002.
Okay. But it's okay. But our goal here is kind of to build to this thing of multiplication, and you're kind of using it along the way. So we're using these bars to represent how is multiplication modeling the situation. Does that make sense?
Yeah.
So you're kind of using it along the way.
Okay.
But it's not wrong what you did. You're right. It's not wrong. Okay. Any other questions? All right, so we'll just introduce the next thing here so I can get this right this time. There we go. Okay, so let's just briefly talk about division. So multiplication gives us a scaled version of another quantity. Okay, and something that we've seen that with rates, rates always have to do with two quantities. And so if we scale a rate, it's like we're scaling both quantities together. That's what we just talked about. Okay, so division has to do with the relative size of one quantity in relation to another. Okay, so let's just, as a last problem here, can you model this? Building A is 17 meters tall. Building B is 5 meters tall. Building A is 17/5, or 3.4 times as tall as building B. Can you model that? Yvonne, did you make a start on it? Tell me what you did. How did you think about this or represent it? Okay. Okay, so you had one bar that was 17 meters, okay. Represented the... So I'm going to actually do little buildings on this one. Same difference if you put them horizontally or vertically. Doesn't matter. So how is this then, this picture showing that building A is 17/5 or 3.4 times as tall as building B? Anybody want to tell me in the red shirt? What's your name?
Trevor.
Trevor.
Well, on each of the bars, I put on like a 1 meter mark,
Okay.
and then that way you have like a measurement, like a unit of measurement to figure out like, how long each one is.
Okay, so that's what this did too. Okay, so that's a 1 meter of building B. Okay, and how much of building B is that? Isn't that 1/5? 1 meter is 1/5 of building B. And how many meters do we have in building A? So isn't that saying that we have 17 1/5? And what is that? That's our division, 17. Taking 17 1/5 is 17/5. So that number 3.4 then represents the relative size of building A to building B, or how much taller it is, A, than building B. And that's from division. So it's like we're measuring, it's how do we measure building A in terms of building B? That's what division does. Measuring this top quantity in terms of that bottom quantity, it's 3.4 times as tall. The division, or the result of the division is measuring building A in terms of building B. See that? Does it make sense? Okay, we'll continue here tomorrow, not yesterday. I posted Wednesday's homework. You're welcome to get started on that if you want. You have
Blackboard or my last?
yeah, it won't be. We won't have my math lab for a little while. So it's on Blackboard. I posted it on Blackboard. You can get started on it. Don't forget the pretest today. PSA 21. Be in there before 6:30.
I'm an econ major, and I transferred from another school. I took calculus over there, and it was kind of like just completely different than this. I don't know if I should switch over to like.
No, of course not.
Well, I know you're gonna say that, but I'm not sure like what direction I should go in everything. Like I don't know if I'm better at word problems like this, or more better at derivatives and things along that line.
Well, it's up to you. If you really want to learn the underlying ideas of calculus and really get it and understand it, that's what we're going for.
Yeah.
So.
It's gonna be completely different, or.
Yeah, were you here on
Yeah, I was
Friday?
here, but I
Yeah,
don't
that's
know
why
if
I
it's-
took 20 minutes
yeah.
to kind of lay that out, that it's going to be really different.
Yeah, and
But-
I don't know if I should stick along the lines of like what I know, because I got a C- in the class and I needed a C to transfer over. But I started the class late, so I missed the first like 3 weeks. So that was the only reason I kind of was like my downfall. I didn't get the initial steps. So
Well, we're
think it out.
we're taking it from the beginning, as you can see. We're building it
Yeah.
from the ground up. So, I mean, it's up to you.
Yeah.
But
Do you know
I'm
if-
not gonna, I'm not gonna encourage you to
Yeah,
to
I understand
do something that I'm less fond of.
Yeah. What is the other kind of math? Do you know what it is? Is it more like a business kind of aspect? Because I didn't look at anything.
Are you talking about changing from 270 to a different course?
Yeah,
Oh, I don't know. So, what is your major?
economics.
So like you need 210. Is that
Yeah, I
what
was
you're saying?
looking at 210,
Yeah.
but I mean it's different than
You
what
gotta-
I've taken in the past. Like
You
I
gotta
took
make sure that
calculus.
210 fulfills your requirement, basically.
Yeah, I know it
But
does.
that's called
but-
brief calculus.
Yeah.
So that's gonna be, yeah, that's gonna be a 3-hour course.
Mhm.
It's gonna be more in kind of the style of what we talked about on Friday.
Okay.
So
You know,
I can't answer it for
no
you. I
problem.
mean,
Thank you. I just need a little bit of advice because I don't know like where to go from here. So, all right, thank you.
I think if you work at it, you could do it if you want to
Yeah.
stay and work at it.
I'll try.
It's a rec book, right?
That's it.
Don't open the recitation.
No,
one.
you can open if you want to use this for reference.
Mhm.
Yeah, and you'll need
The math code.
you need the code. You need access code. That's what you need.
Yeah, but don't open this.
Don't open that one.
Okay.
That's right.
All
That's
right.
right.
Hi, I was wondering, do you do honors contracts?
I'm not sure yet.
Okay.
So just you can email me and remind me,
Okay. All right.
but maybe not,
Thank you.
or maybe. Yes, sir.
See you 12:30 tomorrow.
Yeah.
Okay.
Sounds great.
Yep.
Thank you, sir.
Should we just keep that sheet and just like kind of mark next
Yeah,
to
keep
me?
that'll be your.
Oh, okay.
So, I want to if we can both kind of try to learn the names and then, then you can just look at the table and be like.
I'm pretty sure I got one table down today.
Cool.
Not good with names, but
Okay.
so.
Actually, I have another question for you.
Yeah. See you, Marshall.
This coming
Yeah.
Friday, there's a chance I will not be able to come to class.
Okay.
Do you think I can stay caught up just this
Oh yeah, I
Friday
mean, of
with
course you're
what's
gonna. I mean, yeah. So hopefully,
I don't
I'm
miss
trying to see if
class,
I got
so-
the movie. I
kind
don't.
of freaking out that I might have to miss a class.
What happened? It like never. It's gone. Like I started recording, but there's no movie. There's nothing. It's not even open.
Is there gonna be
so-
anything due this Friday?
Shoot. Probably.
And can I scan and email it to you? Can I?
Oh yeah. So yeah, if you wanna, absolutely, you can. Yeah. So yeah,
Great.
it's great.
Great. Thanks.
Should we be bringing in the recitation notebooks for tomorrow?
No, we're not using the recitation notebook. So you don't even open it. I'm gonna try to let you know if you might be able to get a refund for it, or just get a little bit of money back, maybe end of the semester or something. So no, we're not gonna use the recitation notebooks. Okay, you're welcome.
That was kind of hard.
Alright, so those are the only ones.
Yeah, this is way too big. I was up like 2 hours last night. I was like, how do you do this?
I felt really stupid when I asked about the show one.
I was like,
How am I supposed to know if it's blurry or not? Take a video of it instead of shutter speed and shit. Yeah. I'd be like, set it to the max. Take a video of it.
I was trying to like Google it and stuff, like, yeah. I couldn't even find anything. It's ridiculous. It was hard though. I was up for like 2 hours last night just doing it.
Yeah, that's at my work. I put up to last minute stuff like you can see. I'm over here writing on paragraphs and stuff.
I took up like 1.5 pages to like do all of it.
Like 4 pages? I don't know pages skipping between all.
Now I feel like I didn't need to do it.
I'm just, because I had to do it, like, redo it over again.
All right.
Second question or something. It is. One of them had, how about number 6? Yeah, like number 6.
Number 6, I was just done with it. I was like,
6, I just put a different thing on it. I hope we were supposed to draw pictures, because it said illustrations, but
I drew like a little picture of number 1.
I drew a puppy for number 2.
It's hard to know what he's looking for. He's like,
Wait, so what are we supposed to do for the test today? Do we just go underground and then, or do we have to check in somewhere?
free test or whatever?
Yeah, that's underground. We don't have to check in or anything? Do you know where we have to check in now? It's oh, okay. There's a bunch of errors. Alright.
I hope your test isn't like that.
Super vague calculus. Not enough without the vague.
We have a quiz already.
Yeah, I know.
I don't know what that's going to be about.
Oh, quiz, what?
I got a quiz overall.
Oh. Actually, no, I didn't.
Well, I'm pretty sure it's probably going to be like explain like division means or something like that.
You can still do the reading.
Yeah.
I'm gonna read it again.
Okay, let's get started. Hold on a sec. I just screwed out of it. Maybe not.